Gosh darn it. Oh, there it goes. Okay, plan today. We're going to do 3-1. 3-1. When my alarm goes off, we'll start the quiz. Okay, 6 questions. I told some of them already. I'm telling you right now, I'm embarrassed to give you this quiz. I'm embarrassed. It's not hard. So start the semester off right. Don't focus on that right now. Focus on 3.1. Okay, I'm gonna give you 25 minutes to do the 6 questions on the quiz. Okay, 6 questions on the quiz. Plenty of time. Plenty of time. Plenty of time. All right, here we go. 3.1. 3.1. So what we talked about on Wednesday, right? We kind of started introducing the unit circle. That does not come into play in 3.1. That comes into play in 3.2. So 3.1 kind of just all that, kind of keep it in your head. But on Wednesday of next week, we don't have school Monday. On Wednesday, we'll hit 3.2, and that's where the unit circle comes into play. We're going to spend 2 days on 3.2. We're going to spend 2 days on 3.2. Okay? All right, so 3.1. 3.1, periodic phenomena. What I'm going to tell you today, guys, listen, will be a free response question on your test, on the next test, on the next test, and on the AP test. There will be a question that comes from this, comes from your worksheet, that comes from your homework. A free response question. Right? I told you this is one of the rare classes that we know what the questions are going to be, or at least we know what they're going to entail. Not necessarily exactly how they're going to be worded or everything else, but we know what you need to know for them. Okay? And so we're telling you, we know one of the questions is coming from this lesson. Okay? You'll see it so much, I think it's going to be just fine for you. All right. Periodic relationship. This is kind of really what starts trigonometry, one of the things, okay? Periodic relationships between 2 variables occurs when the output values demonstrate a repeating pattern over successful equal length intervals. So, boom, 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 and it looks like it's starting right back over. Same thing, right? Periodic, repeated patterns. This repeated pattern looks like it goes from -1 to 3, and then from 3 to 7. So it must go from 7 to 11 and from 11 to 15. Y'all okay? So every 4 units, it repeats. Okay, with all that kind of stuff, just kind of start thinking about those type of things. The period of a periodic function is the length of the x values that it takes for the function to complete one cycle. Guys, I don't know what is so focused in on these computers, but I don't think there's anything you need to be looking at them today, right now. Okay with that? So in this particular one, this period is 4 units. Okay? Now, later on, it might be different values down here. Those are things we need to make sure we be aware of. But that's what we're talking about. Everybody kind of okay so far? Periodic function, it just repeats. Hit me.
So if it's periodic, we will have to like assume that it can be like the interval will tell us that it's periodic.
It will. Yeah, it will say it's periodic, so we know it repeats. That's good. We don't have to assume that, right? You've seen piecewise functions before. This is kind of like a piecewise function, except we know it's just going to continue, right? It's linear, it's constant, it's linear increasing, linear decreasing, linear. So this is kind of like what 1, 2, 3 different linear parts, if you want to kind of think about it. You guys have seen piecewise functions that would just do that. Maybe not segments, maybe they were arrows, but yeah, if it will tell you it's a periodic function. So therefore, we know it repeats. We know it repeats. Okay? Example number 1. So again, we're just going to jump right into the examples because once you kind of just start understanding this, that's all we need to know. This function is periodic with a period of 4. So they're telling you it's periodic with a period of 4. I don't even have to figure that out. A portion of the graph is shown. So we can see what? I see 2 periods of it in the graph. Draw 2 additional periods. So they don't care if you draw them to the right, draw them to the left, 1 to the left, 1 to the right. I just got to draw 2 additional periods. Easy enough. Y'all okay? So here we go with our little pencils. I'll make it blue or red or gray. Let's blue. So up 1 over, up 2 over 2, up 2 over 2. Y'all kind of just see what I did there. And then I'm going to go over 1 unit, over 1 down 2, over 1 down 2. Makes it fairly nice. And so boom, boom, boom. There, I drew one of them. I got to draw one more, and I can just continue on this way. You can go to the left if you want to, but because I got stuff to the right, I'm just going to make it to the right. But it doesn't matter. That's what I go on to say. This makes it a little bit more difficult, but this is the time of year where there's going to be a bunch of different answers, and they're all going to be correct. They're all going to be correct. So up 2 over 2, over 1, down. Beautiful. Okay? Any question about that? I hope that's fairly easy for you guys to understand. Periodic function. Periodic function. Beautiful. Example number 2. A portion of the graph of a periodic function g is shown. Again, these are functions because they pass the vertical line test. It's never going to kick back around and do something weird. They're going to be functions. They're going to start somewhere and end somewhere. I don't know if they really want to start somewhere and end somewhere, but y'all kind of okay. What is the least possible value of the period of g? The least possible. So we kind of understand this too. I could call this period 4, or I could call it 8 because it repeats. This is 8 and it repeats for 8. They want the least possible value. Okay, so that's why this one you can't have several answers. You can only have one. So I don't care where you start. You guys, some of you guys may start at the bottom of that V. You may start at the very beginning. You may start somewhere else. I don't care where you start, but at one point you start, it starts repeating. And so that distance is the period. That distance is a period. So if I want to start right here, well, let me go back to a pencil again. If I start it right here, it goes horizontal 2, it goes, drops over 1 down, it's coming back up, and then I'm going over horizontal 2 again. And so this looks like the distance where it starts repeating. Again, that's just where I chose. Some of you might choose the bottom of the V. This is where I want to start. Either way, if that's where you start, here's where it starts repeating. That distance between the pink, whatever color you want to call that, is the same as the distance between the blue. So either way, we'd all have the same answer of that. What is that? 1, 2, 3, 4, 5 units. Good enough? Y'all okay? I'm not seeing any blank looks, so I guess we're okay. What is the least possible period of, so 5. If you want to. Good. We'll have on your test, this will be a word problem. So typically that will be like minutes, hours, days. Mostly it's time. Okay. But it will tell you what that is. Using G, in example 2, find the following values. G of 14. Well, I do not want to draw this out 14. Because if you look ahead, 72, I'm for sure not going to draw that thing out 72. So because it repeats every 5, it actually also repeats every 10. And that makes it really nice because G of 14 will be the exact same value as G of 4. And if you don't want to go 10, then you'll just go 5, which is 9. Oh, and I actually have 9, so I could use 9. And if you don't want to use 9, we'll use 4, because again, those are the same values. And if you don't want to use 4, we could use -1. Anyway, any one of those you want to do, but that's kind of how you work on that. And so it's nice that it's 5, because like I said, that's 10. Good enough? Uh-oh, did I get there? I got there, good enough. So what did we decide that was? 7. 7. G of 14 is 7. I apologize. You guys are way in the back. I know that's way, way, way low. Now I got 72, 62, 52, 42. Bless you. 42, 32, 22, 12, 2, 6. Good enough? 6. When I get all the way out there to 72, that's where I'll be. I'll be right there at 6, and I'll be actually halfway between that line going up again. So again, it repeats all the way out there. Negative 17, negative 17, negative 7. Uh-oh. 3. Don't go to 7, right? Because that switches things. So from negative 7, 10 more puts me at 3. 7. And I don't know how much work needs to be shown there. If you want to show, if that was a test question, we don't like naked answers. You probably want to show like adding 10, adding 10. Y'all okay with what I'm saying on that? I mean, they could have made it a little bit harder by choosing like 4 or 3 or, something else, but. Beautiful, beautiful. Here we have another graph of a periodic function. What happened here? And it tells me it has a period of 5. I don't need to draw it. It's a table. It's a table. So I'm going between 1 and 3 and 4 and 7. I don't necessarily know exactly what happens at 2. I don't necessarily know what happens at 3.5 or 5, or I really don't know, right? Anytime they give me these points, we don't assume it's connected with straight lines. It could be curved. It could be all kinds of things. We can't assume. So I hope they give me something that lines up with these values. And if they don't, we have to say, I don't know what it is. Y'all follow along with that, right? Again, don't assume it's going into straight lines. Periodic functions could do curves. In fact, a lot of them do curves. That's what the trig part is. A lot of them do curves. So h of negative 2, and it's a period of 5. So I don't have a negative 2, so I could add 5 to negative 2. If I add 5 to negative 2, I get 3. I got 3. I got 3. So if you want to, again, just add 3 or whatever you want to do, but I don't care how you do it. If you get a 0 right there, I'm good. Get a 0 right there, I'm good. 6, I don't have a 6. Add 5 to 6, I don't have 11. Subtract 5 to 6, I got a 1. Good enough? Okay, I hope this is easy. I hope. Uh-oh, dadgummit. H of 9. I got to do the inside first. H of 9, I don't have a 9. Add 5. I don't want to add 5 so I'll subtract 5. That's 4. And then I got H of 3. Uh-oh, well, we got harder now. So now I got to do H of 3. Oh, and I have a 3. Sweet, 0. That was nice. That was nice. Any question over that composite function? Uh-oh. H of 5k minus 3, where k is an integer. So k is 1 or 2 or 3 or negative 1 or negative 2 or negative 3. So if k is 1, that's 5. 5 minus 3 is 2. That's h of 2. Stop. What if k is 3? If k is 3, that's 15 minus 3. 15 minus 3 is 12. Y'all starting to see a little pattern here? Hit me.
So if the slope is the same as the period, does it matter what you put in?
No. Y'all okay? Kind of what I'm saying? Because at 2, I don't have, I don't have a 2. Oh, I got to subtract. No, I did that. Where k is an integer. 2, 12, 7. Oh, I can add 5 because it's a period. Y'all good? Right? Because at 2, I don't have a 2. but it says a period of 5. So I can add 5 to 2. And if I add 5 to 2, I'm at 7. What if I add 5 to 12? I'll be at 17. That doesn't help me. Subtract 5 from 12. I'm at 7. Guess where I'm probably going to end up every single time? 7. I'm going to end up at 7. And if I end up at 7, that value is 2. That value is 2. So it gets a little bit more difficult on some of these type of things to see that, okay? But you can plug in any number you want, whatever number it might be. It doesn't really matter because the period is 5, right? So because they have that 5K, they're probably going to do something. I mean, you should be able to figure those out. Beautiful. All right. We're going to talk about a little bit more about notes. It is useful to have a notation to model this phenomena. A periodic function starts with a basic pattern and translate repeatedly over the domain. Whatever. As a result, we're able to consider a periodic function as a horizontal translation of itself. In example number 4, the period of h was 5, meaning that we could translate the graph of h horizontally 5 units and end up with the same graph. This means that this function h satisfies the following equation for all values of x. We kind of did that in our head because we subtracted 5 and added 5, and okay. You don't have to put h is equal to x minus 5. We could put h is equal to, or not h equal to, h of x minus 5. We could put h of x minus 10 or h of x plus 5. But it doesn't matter if I add 5 or subtract 5, I'm going to be at the same points. Y'all okay with all that? Good? And like I said, that's where one of those type of things where we may have several different answers going on here. Example number 5. The graph of f is a periodic with a domain of all real numbers. That means it starts at negative infinity and it goes to positive infinity. 2 full periods are shown. Find all input values of f that yield a value of 1. So I need to yield a value of 1. There's going to be a bunch of those, right? What's this one? F. F. Two, 6. One, 2, 3. That's another 5. Is it repeat every 5? 4? That would make sense, right? 2 and 6. So 10, 14, negative 2. Good? Somebody? You want to do 4x minus 2? If I plug in 1, do I yield a 1? If I plug in a 2, do I yield a 2? Oh, sorry, a 1. I need to plug in any number I can, integer preferably, and yield a 1. So 4 comes out with the period, and then the negative 2 comes up with this shift. And I don't have to, this is not the only answer. It's not the only answer, but it's one that works. It's one that works. This one's going to be a multiple choice question. That way only one will work. That way I don't have to grade 29 different answers. Okay with that? So you kind of look at the period and then you look at the shift. You look at the period and you look at the shift. This thing is kind of shifted, if you want to talk about it that way, 2 units to get that thing lined up. 2 units to get it lined up. Just like the one that we kind of just did in the previous example, D. You will get tired of seeing this picture because it comes up and it comes up and it comes up. This is the free response question. It won't be a clock, but it could be something. So let me go through this the best I can. How am I doing? Oh, we got plenty of time. The figure shows a large clock mounted to a vertical wall. I can see that. It's not drawn to scale. The clock has an 8-inch long moving minute hand. Okay, so that's 8 inches. I guess that's the minute hand. There's a minute hand, and I guess there's an hour hand. The center of the clock is 120 inches directly above the floor. I didn't want that to happen. Here we go. The center of the clock is 120 directly above the floor. Okay. At time 0, the minute hand is pointed directly up at the 12 o'clock, whatever o'clock it is. At 0, it's straight up. That's kind of nice. That helps me at least make sense. I'd hate for it to be time 4 and it be 0, but that could be a happen too. However, the clock is not working properly. And the minute hand is moving twice as fast as it should. Thus, the next time the minute hand points directly up at 12 is time is equal to 30 instead of the 60. As the minute hand moves, the distance between the end point of the minute hand and the floor periodically decreases and increases. The minute hand moves, the distance between the end point moves closer to the floor. This is 120. Did it tell me how? It didn't tell me how big the minute hand was. But this is 120. So we're further away from the floor. It did tell me? 8 inches. Oh, so it's 128 away from the floor at the start. And at some point, we become 120 from the floor. And then at some point, we become 112 from the floor. But then we start getting closer to back to the 108. So y'all kind of see that, good? So we're starting furthest from the floor, but we get closer to the floor, 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 closer to the floor. But then we get further from the floor, further from the floor, further from the floor. You got to, I'm telling you, this is going to be, if we don't see this, you're going to have issues. I hope it's fairly easy for you to somewhat understand. We're not going to have issues. Your grade's going to suffer. How about that? As the minute hand moves, the distance between the endpoint and the minute hand, okay, period. The periodic function h models the distance. The periodic function h models the distance in inches between the endpoint of the minute hand from the floor as a function of time in minutes. The graph of h is the dashed midline for 2 cycles is shown. You will see this so many times. Hopefully you have no questions like what I'm supposed to do. This is a question on the AP exam, and it will look almost identical to this. Probably won't be a clock, but at some point you're going to have this. And notice how this one is not straight lines because it's a circle, right? Distances of a circle are periodically, and their ratio is 2 pi r. It's not a constant, bless you, it's not linear. Determine possible coordinates of t, h of t for the 5 points F, G, J, K, and P. Possible points. 28 of you cats in here, there's 28 possible different answers. But possible. Good? So here we go. I like to look at that first. We're going to call that the midline. Fair enough. And what's the distance of that midline? Was it 120? It said the center of that is 120. And so we must know, again, the radius or the clock radius was 8. So this up here on top has to be 128. Uh-oh, got messed up. And this down here has to be 112. Y'all okay with that? And that's, I haven't done anything yet, but that's just at least helping me realize, hey, those are the Y values. Those are the Y values. And there's 28 of you cats in here, and those better be the Y values because they can't change. Those have to be constant. Now, this part right here is the midpoint, but that's not F or G or J or anything else. They start F right here, which basically means I'm starting F at the 12 o'clock because I'm furthest away from the floor. And so that value could be 0, 128. And if you didn't want 0, I guess it could be 30, 128, because it said 30 minutes, it comes back around. I'm doing that backwards, I think. So it could be 30, it could be 60, it could be 90, it could be infinite things. But I like 0 because that's just easier for me to work with. And if it's 0, then this one over here is 1 complete. That's going to be 30. But again, if you start with 30, then that's going to be 60. It's okay for all that stuff. I just think 0 is easier to work with. So this one over here, P, is going to be, what did I say, 30, 128. And if that one's 30, J has got to be halfway between that. So J will be 15, except it can't be 128, and it's not 120, it's the 112. And you guys will do a little bit better job of labeling all this stuff, but you make sure you're labeling these things correctly. Okay? And then I got, let's see, F, J, I got to do G and K. And I promise you, G, well, it's going to be 120. I just got to go halfway between 0 and 15. 7.5. They're okay with 7.5. If you want to put, what is that, 15 halves? Whatever. I just put 7.5. Make it easy. And then so K, I don't have a whole lot of room anymore. I'm just going to go over here. That's fine. I don't care where you do it. You just got to label these things. So halfway between 15 and 30 is 7.5 more, 15, 16, 17, 18, 19, 20, 21, 22 and a half. 22.5. Where are we at? 120. Yes, no, maybe? I don't think it's a really hard question for a free response question. But I'm telling you, you're going to see this so much this semester that by the time you take the AP test, you're going to think, gee, Minnie, Christmas. Good? Refer to the graph of H in part A. The T coordinate of G is T sub 1. So again, they're doing a whole lot of mathematical knowledge right here that starts to try to make it confusing. But you guys are too smart for this. And the T coordinate of J is T sub 2. So G is T sub 1 and J is T sub 2. Now this is what they'll change, right? It won't be consistent. So here, oh, I don't want an eraser, I want a highlighter. Uh-oh, I didn't want that either. That's what I wanted. Undo, undo. I can't undo, undo. Erase. There you go. What the heck? I don't know what it's doing. Whatever. I love this board. Okay, whatever. On the interval from T1 to T2, which they might as well say from G to J, which of the following is true about H? Oh my gosh. So we're headed what? Downhill? Concave? up. Oh. Concave up. H is positive and decreasing. H is positive. Oh, no, that's not what I was going to say. I got an alarm too. But H is negative and increasing. H is negative and decreasing. What is H? Negative and increasing because it's concave up and going downhill. Hit me. Well, and that's why I'm confused about. So let's look at it real quick. Where's my arrow? The graph of H. The graph of H is dashed middle between it. So you think, yeah. Y'all okay? It's not H of t. H of t is the y value. H is the graph. So it's decreasing because it's going downhill, and it's negative increase. It's increasing at a decreasing rate, right? Because it's concave up. Describe how the rate of change, here it is, changing over the interval as it's T1 to T2. So it's, what was it? Describe how the rate, that's the slope. So it's concave up. Hit me.
So it's negative and decreasing?
Negative and increasing. Describe how the rate of change. So the rate of change is that concave up. The rate of change from here to here. At first, it's like this, right? That's the slope of it. So it's negative, okay? And it's getting closer and closer to 0. Because right here at J, the slope is 0. Right here at G, it's like negative, I don't know, 1. Who knows what. It's getting closer and closer to 0, so therefore it's increasing. So it's decreasing at an increasing rate, that's what we said right here. Yeah. Oh, you wouldn't think it would answer the same thing twice, right? So I think H is positive. H is positive because H is way up here at top. It's like 120 and decreasing. Y'all okay with that? This is what they're looking for in the next answer. That letter C. Kind of, you guys, that's when you start thinking like, wait, did they ask the same question twice? No. All right, so H is positive and decreasing because it's positive. It's way up there at top. It's like 100, it starts at 120 and ends at 112. So H is all positive. Decreasing because I'm going downhill. And then they want to know about the slope of that. And that's where it's decreasing at an increasing rate. And that's it. That's it. Yes, no, somewhat, maybe. For homework, I'm going to give it to you in just a second, okay? And then you'll have you got a little bit of time to look over anything that you want to look over but I'm serious. I'm embarrassed to give you this quiz. I'm embarrassed. I really think the only thing I'm going to take off is when you forget the units of measurement or you forget the little degree symbol. Don't do that. But if you do, if I take off for something else, you just don't have a clue what's going on. I don't know how else to say it. I'm not calling you, I'm just calling you way underprepared. Yay? Your homework, so it's going to be a little overwhelming when I give it to you, but understand there's a whole lot of pictures. Okay, so there's not a lot of problems, but there's a lot of pages. And so I'm going to give you, this is worksheet A. Worksheet A, and it has 11 questions. 11 questions. I'm going to give you worksheet B, B, C, D, E. You do A, B, C for homework. B has question 1, A and B. Question 1, A and B. Yay? And there's a D and a C. So this is a seesaw going up and down. Distance goes away. Seesaws go at an arc. Nice little picture. I don't know if you guys can see it, but it looks just like that one. It does F, G, J, K, P. Oh, this one does F. This one's a Ferris wheel. Huh? Ferris wheel. You're farther away from the ground, you're closer to the ground. A propeller on a boat. Uh-oh. Propeller on a boat probably means we're at negative values. Maybe, I don't know. Propeller on a boat. We don't even have to do that one. This one's a fan. I guess it goes around this way. Who knows? This one is a car that drives around in a circle. Yay. A, B, and C are what I want you to turn in. A, B, and C is what we're going to require quite a bit of scanning because 1, 2, 3, 4, 5, 6 pages. But just get them in there, get them uploaded. You got till Wednesday.